Good afternoon, everyone. We'll just be starting in a minute or so. So, hello, everyone. My name is Rushi Shete, and I welcome you all to the first online event of Zenith Astronomy Club. And we're very lucky to have with us today Bhargav Joshi, who has been a volunteer of Jyotirvidya Parisanstha, which is the oldest association of amateur astronomers in India. And he has conducted many lectures in various schools and colleges about space and space science. And in 2018, as a representative of JVP, he was elected as a mentor of astronomy for the Inspire internship camp, which was organized as a part of the Department of Science and Technology, Government of India. And in future, he's going to be pursuing his master's in mechanical and aerospace engineering from the University of California, with a specialization in computational fluid dynamics. So we're very honored to have you with us today, Bhargav. And without any further ado, let's begin with the talk. So over to you.
Okay, thank you, Rishi. So let's begin with the talk. I'll just present to you the PPT. Just one thing in mind, there is some background noise because of the rains. Okay, so just bear with it. So let's start with the presentation. Okay, right. So can everybody see the screen? Rishi, can you tell me, can you see the screen?
Yeah, you're visible and audible completely.
Okay, perfect. So yeah, today's lecture is going to be about the introduction to solar system and the other elements of cosmos. So this is basically organized by Jyotirvidya Parisanstha, and it is one, as Rishi said, it is one of the oldest association of amateur astronomers. Okay, so I work there as a volunteer. So this lecture is basically everything about our solar system, the cosmic calendar, and cosmic address. So now everything in astronomy starts with what you can see. Okay, so there are some things in the sky with which you can see, and those are the telescopes, and through the telescopes you can see everything in the sky. But even without the telescopes, there are some things which can be seen with the naked eye. So the sun and moon, of course, can be seen with the naked eye. Apart from that, we have 5 planets, that is Mercury, Venus, Mars, Jupiter, and Saturn, which also can be seen with the naked eye. Most of the people are unaware about this fact. And through the telescopes, of course, we can see even the moons of those planets. So these are some of the objects that can be clearly seen with the naked eye and that are in our solar system. So the outline of the lecture will be introduction to our solar system, then beyond our solar system. So that means our cosmic address, where exactly is our solar system in the entire universe. And then we have the limits of humanity. So there are certain limits, rather cosmic limits, to how far we can go and how big is the universe and how old is the universe. So that will be discussed in the third point. So yeah, introduction to the sun and the planets, our solar system. So before starting with the solar system, let's start with our home planet, planet Earth, because we can use planet Earth as a reference for everything in the sky. Astronomy literally means the law of stars. If you split the word, astron means a star and nomi is the study or the law. So astronomy is the law of stars. It deals with measurements and timekeeping basically. So Earth is considered as the reference. In all the ancient civilizations, Earth was considered as the center because the systems were geocentric. So split the word, geo means Earth and centric means center. So we start with our planet Earth, which is, let's say you want to define your cosmic address, like we define our own address. So we have a building in which you live, then you have the society in which you live, then you have the city or the area, then the district, the state, and the nation. And we keep on expanding. So similarly, in order to define the address of humanity in the entire universe, this is the first line of cosmic address, or this is your building, planet Earth. So now let's take a look at planet Earth. So every time a planet comes up, you will see a list of parameters. So we don't need to get into details of all the parameters. We just need to make some important points that we can relate to other planets as well. So the first thing, distance from the sun. So if you see the distance that is given in the tabular form, that is actually the mean distance, 150 million kilometers. So that is because the Earth revolves around the Sun in an elliptical orbit, so there cannot be at a constant distance. At some point of time, Earth is closer to the Sun. That point is called as the perihelion. If you split the word again, peri means nearer, and helion comes from the word helios, which stands for the Sun. So the point which is closer to the Sun in the Earth's orbit is called perihelion, and the point which is farthest from the Sun in the Earth's orbit is called the aphelion. So this is actually the mean distance that is calculated from these two distances. And it is also represented as one astronomical unit. So 150 million kilometers, the mean distance between the Sun and the Earth is called one astronomical unit. Now you can take a look at all the other numbers. You can easily access those numbers on any of the Wikipedia pages. There is no concept in this, just to make you understand that we are going to use these parameters to understand other solar system objects. So now the important thing here is the rotation period, the length of solar day, and especially the axial inclination. So you must be knowing that the Earth is not exactly straight. It is inclined by an angle of 23.45 degrees, or roughly 23.5 degrees. So it is not exactly straight, it is inclined slightly outwards. So that is called the axial inclination. So take a look at these parameters, and we are going to relate them to the other planets in our solar system as they come by. So yeah, one of the most important questions that has been bothering humanity since the Greeks is the seasons on Earth. So ancient Indians knew about the seasons on Earth, the Greeks knew about the seasons on Earth. But the thing is, we need to understand what causes the seasons on the Earth. So many people believe that summer occurs when the sun is closer to the earth and winter occurs when the sun is farther from the earth, but that is a major misconception. Distance between the sun and the earth does not cause the season. Seasons are completely the effect of the axial inclination of the earth, which we saw in the table before, 23.5 degrees. So now let's take a look at the picture in the front. Now let me tell you, this is not a scaled model. As you can see, the sun is shown smaller than the earth. This is called a diagrammatic representation, or rather a schematic, for us to understand the astronomy behind it. This is not a scaled model, and this is just a diagram. Okay. So now in this diagram, let's try to focus on the image on the right. So we can see the earth with a cone on both the sides. So as you can see, the earth is tilted, and the tilt is shown here, 23.45 degrees with the green arrow. Now what happens is, this point where the northern hemisphere of the earth is tilted away from the sun. At this point, there is winter in the north, and naturally there should be summer in the south, because the earth is tilted that way that the north faces away from the sun. So this point where the winter occurs in the north is called winter solstice. Okay, start of winter in the north, and this starts on 21st or between 21st to 23rd of December. Okay, so this is the first point. After winter solstice, the earth is moving ahead in the clockwise direction. The next point which comes in, as you can see on the image, is called the spring equinox. So this is actually where the spring season starts in the northern hemisphere. So remember, everything that we use as a parameter is treated with respect to the northern hemisphere. Okay, there are certain calendars which also make use of southern hemisphere, but most of the astronomical treatises use the northern hemisphere. So yeah, if you can see the position of the spring equinox, both hemispheres of the earth are getting equal amount of light. Okay, hence the term equinox, equal amount of light. And this is the spring equinox or the vernal equinox. In our ancient Indian terms, it is called as Vasanta Ritu. You must be familiar with it. So this is where spring equinox occurs, and this occurs between 21st to 23rd of March. Okay. So now after this, the earth keeps on moving. and continues in its orbit until it arrives at a similar position. Now what you can see is the northern hemisphere is tilted towards the sun. So naturally, in the north there should be summer, and in the south there will be winter. Since it is summer in the north, it is called as summer solstice. And this occurs between 21st to 23rd of June. Okay? So that is when it is summer in the north. And again, when the Earth continues its motion in its orbit, we arrive again at a similar position to the equinox. Only this time, it is called as the fall equinox. And this season is the autumn season. Okay, so this occurs in the month of August. So what you can see here are all the cardinal positions which are responsible for the seasons on planet Earth. We start with winter, then we have the spring, then we have the summer, and finally we have the autumn. So as you can see through the diagram, the seasons are merely the effect of the inclination of the Earth and not the distance from the sun. Okay, just keep this in mind. Seasons on Earth are due to the axial tilt, and this is how they are caused. So now there's an interesting phenomenon. In school, we have learned about two motions of the Earth, but in actuality, there are five motions, out of which we are going to discuss three. So of course, the first motion of the Earth is very simple, the rotation of the Earth around its own axis. So that's rotation. The second motion is revolution. Okay, the second motion is revolution, which means the Earth is revolving around the sun. So that's revolution. But there is some other motion of the Earth which was not taught to us in school, and that motion is called axial precession. So if you can see the GIF on the right hand side, you can see that it is not just the Earth that is rotating, but the axis of the Earth itself is rotating. So this situation is similar to a top. So you must have played Beyblade when you were a child. So what happens is when the top is at its maximum speed, it is exactly straight, the axis is exactly straight, and it is spinning around its own axis. But then what happens is, as the top becomes slower and slower, the axis itself starts wobbling. Okay, so this is what happens with the axis of the Earth. So right now, the axis of the Earth is tilted at 23.5 degrees. That axis will cover an entire circle as shown in the left hand side of the image. And this period takes almost 25,800 years to complete one circle. So rotation is of 24 hours, revolution is of 364 days, and axial precession is of almost 26,000 years. So these are the other motions of the Earth. So yeah, so the next parameters are moon, a natural satellite. Now again, these are some of the parameters that you can find anywhere on the internet. Just make a note that the weight of an object on the surface of the moon is 1/6 that of the Earth, because the gravity on the moon is 1/6 the gravity of the Earth. Yeah, so this is one of the most important things to understand. On the right hand side, you can see a diagram where the moon is revolving around the Earth. Okay, so this revolution period takes about 27.32 days, which means the moon takes 27.32 days to complete one revolution around the Earth. And this period is called a sidereal period with reference to the stars. But now what happens is, if you can see the images on the left, in the first image, you can see the position of new moon. A new moon occurs when the sun and moon are on the same side, which means they are in conjunction, not opposition. Okay? Amavasya, which we call it. Now what happens is, after a period of 27 days, the moon is back to its original position. But now what happens is, during that time, the Earth has moved ahead. So the moon requires some extra 2.9 days to fill up that gap. Okay, so this sidereal period is then added into 2.9 days to give us, yeah, so this is what you can see. This period is called as synodic period. Okay, so just to clear out, moon takes 27.3 days to complete one revolution, but then again, the orientation has changed. Okay, the stars at the background are the same, but the orientation has changed. So in order to achieve the same orientation as well, it takes extra 2 days. So that is shown in the image on the left hand side. So the top image shows the new moon, the sun and the moon closer to each other, and the image at the bottom is again closer to each other, but that requires 29.5 days. This is called synodic period, and this is used for the calculation of calendars in ancient Indian as well as Greek and Roman mythologies. So yeah, you must be knowing about the phases of the moon. We have the full moon as Purnima, new moon as Amavasya, and this is how it actually works. Now the question that you might have is, if moon, earth and the sun are in a straight line as seen in the figure D, where it is a full moon, how is it possible that it is a full moon? Because if the earth is blocking the radiation from the sun, then how come it is a full moon? It should actually be an eclipse, rather a lunar eclipse. The thing is, the orbit of the earth and the orbit of the moon are not in the same plane. The moon revolves in a slightly tilted orbit. So imagine the left hand side of the picture is coming out of the screen and the right hand side of the picture is going into the screen. Okay, so the moon revolves in a tilted manner and it revolves at an angle of 5 degrees. So the orbit of the moon is tilted by 5 degrees to the orbit of the earth. So that is why every new moon and full moon we do not have eclipses. They only occur at two nodes of the moon. Okay, so those two nodes, the diagrammatic representation and the video, you can find anywhere on YouTube. It is explained really good. But this is the basics. This is because of the non-coplanar orbits of moon and the earth. So yeah, this is the sun. So our sun, if you can see the parameters, just take a look at the mass of the sun. So the figure on the right multiplied by 10 raised to 24 kgs. So the sun is a really massive object. Okay? The sun is so massive that it can almost fit 500 million Earths inside the sun by volume, of course. Okay, so mass is really important in terms of a solar system because mass determines the gravity and gravity determines the motions of the planets around the sun. Now, even though the sun is so huge, the sun is so bright, even then the sun is just an average star and it appears bright because it is so close to us. There are stars which are bigger than the sun in size, in volume, by mass. Some stars are so huge that you can fit 500 suns inside those stars. So now you can imagine such a huge star. Now, as you can see, the sun uses 400 million tons of hydrogen. So imagine, this is like, let's say, you make an atomic bomb which has the fusion energy equal to one atom of hydrogen. Now imagine 400 million tons every second. So that gives you a pretty fair picture about the sun. The temperature at the core of the sun is 15 million and the surface temperature is 5000 degrees Celsius, almost 5000. So it is, of course, it is really hot and it is a star, and that energy is arising out of nuclear fusion. It is a process in physics, so let's not get deep into it, but just remember the process, nuclear fusion. So this is a relative scale. This is rather a scaled model, and as you can see in the background, the Earth is merely a dot in front of the sun. It is rather so minuscule that it can, of course, be ignored. The sun is so huge and it dominates the entire solar system. So this is a picture which represents the masses of the objects. So the mass, or rather you can say out of the total mass of our solar system, 99% of the mass of the solar system is occupied by the sun itself. You can see the blue portion of the pie chart. This entire area is of the sun because 99% is inside the sun. And the rest of the planets, including Jupiter and Saturn, you can see a very sharp line of Jupiter and even sharper line of Saturn. So that is how small and minuscule and you can say puny the planets are as in comparison to the sun. So now what about the structure of the sun? So the core of the sun, as you can see the diagram, they have shown a graph. And in that graph, now the really funny thing is you can see the photons they have represented. But the thing is when the photons are created, a photon is a particle of light according to Einstein's theory of relativity and Einstein's photoelectric effect. A photon is a particle of light or a quanta of light. Now, the thing is, inside the surface of the sun, when a photon is ejected from the core, it takes almost 100,000 years. It might take even thousands of years to reach to the surface because the sun is so dense that the photons start colliding with each other, and the collisions are so much that it almost takes 1,000 years for the photon to reach the surface. Imagine, the photon takes 1,000 years to reach from the core to the sun surface. But as soon as the photon reaches the surface of the sun, from there, it merely takes 8 minutes to reach planet Earth. And if you remember, the distance between Earth and the Sun is 150 million kilometers. Okay, even then, photon takes just almost 8 light minutes. But when it is inside the Sun, it might take thousands of years to reach from the core to the surface. And that is because of all the collisions that happen. And that is what is shown there. You can see a random scribbling pattern that is called a Brownian motion. So now regarding the solar atmosphere, there is a very interesting phenomena that is still a mystery to astrophysicists today. So by logic, if you see, the temperature should be highest at the core of the sun, which is of course 15 million degrees. And as we go outwards from the core, the temperature should decrease, right? Makes sense? So the surface temperature is in fact 5,000 degrees. It is lesser than the core. But then here's an interesting phenomenon. There is a thing called as the corona, okay, and not the corona that we have right now. This is the real corona. The coronal mass ejection is where this comes from. So the corona of the sun is the outer layer of the sun. So again, if you go by logic, the heat or the thermal energy should be reduced as you move away from the core. But this is where it gets interesting. The temperature of the corona is actually much more than it is expected. And physicists and scientists and solar physicists are really stumbled upon this fact. And that is why we had launched a mission called as the Parker Solar Probe, named after Eugene Parker. And that probe is going to study the corona and why the temperature of the corona is so much higher than it is expected. So this is one of the most interesting and unsolved mysteries about the sun. So yeah, these are sunspots. So as you know, the sun consists of magnetic fields, and all the layers of the sun are formed because of a process called nuclear fusion, which radiates heat. But in some regions, the heat actually decreases because it radiates too fast or radiates too more. So these cooler regions can actually appear as black regions, and you can see these sunspots through the telescope. These sunspots can be clearly seen through the telescope. Rather, there is a sunspot cycle which repeats after every 11 years. So this is one interesting phenomenon. So now after the sun, we now move on to the planets. So of course, the inner ones are called terrestrial, which means they have the solid surface. The outer planets are gas giants. So this is regarding the definition of a planet. So we just need to focus on the last 3 lines. For a definition of a planet, the object must orbit the sun, and it must be big enough in its own orbit to become like a round ball. So now this definition of the planet has actually been defined by IAU, and since Pluto does not fit in this definition, that is why Pluto has been demoted from the rank of a planet. And now if you see, this is a size comparison. So literally the outer or the gas giants, they are so much bigger than the interior planets. Jupiter and Saturn being the largest, and you have Uranus and Neptune. This is the size comparison of the inner planets. So you can see Earth and Venus are almost of the same size, which is why they are also called as the twins. And then we have Mars and Mercury. So Mercury is actually the smallest planet, and you can see Pluto is included here because this image is from before. But right now Pluto should not be there because it has been demoted from the rank of a planet. So Mercury is the smallest planet, and Mars is the second smallest actually. You can see the Earth is so huge as compared to Mars. So yeah, so the Mercury, it is named after the Roman god, the winged messenger. And now let's take a look at the parameters. Now this is an interesting thing. If you look at this parameter, axial inclination, the axial inclination of Mercury is just 2 degrees. In the case of Earth, it was 23.5 degrees, whereas in the case of Mercury, it is just 2 degrees. and the distance is hardly zero point 0.3 astronomical units. So it is really, really closer to the sun, which is why life will never be possible on Mercury. Now, regarding the orbital period and rotation period, there is an interesting phenomenon. So let's take a look at that. So yeah, of course, these are the certain parameters like the temperature. So the day temperature is 420 degrees Celsius. Night temperature is really, I mean, minus 180 degrees Celsius. And the thing is, Mercury is a terrestrial planet. Mercury also has a core, it has a mantle, and it has a crust. But the thing is, the core of the Mercury is so huge that it occupies 85% of its radius. Okay, that it is that huge. And because of having such a huge core of the Mercury, the planet has shrunk by 4.4 miles since its inception. Okay, so Mercury has actually shrunk. When it was formed in the early stages of formation, it was much larger. Now it has shrunk by 4.4 miles because of the inner core of the Mercury being so huge. This is one of the most interesting thing on Mercury. If you actually try to look at on the internet, the revolution period of Mercury, which means the time that Mercury takes to revolve around the sun, is 87, almost 88 days. But the thing is, its rotation is so slow that it almost takes 115 days to rotate. Okay, these days meaning they are Earth days, of course, in the terms of the Earth. So the mean line is a year on Mercury is actually shorter than a day of Mercury. So if you're living on Mercury, the year will come faster as compared to the day on Mercury because the definition of a year is a revolution around the sun and the definition of the day is from sunrise to sunrise. But because Mercury is so slow in rotation, the sunrise to sunrise actually takes longer time on Mercury and the year becomes shorter. So this is one of the most interesting things on Mercury. A year is shorter than a day. Yeah. So if you can see, this is a clear. This displays the elliptical orbit of Mercury. The left-hand side, the point on the left-hand side is peri, and the point on the right-hand side is ap. So perihelion and aphelion. But the thing is, the orbits of the planets are also not fixed. They keep on moving. Okay, this entire thing is called as the nodal precession or the apsidal precession, which means the orbit itself is shifting, and you can see the shift is given on the in the text below. So this is called as nodal precession, and this does occur in the case of Mercury, and it can be predominantly detected. So yeah, so the next planet is Venus. So Venus is named after the goddess of love, and it is an ancient Roman goddess. Now, recently, a very interesting phenomena has been come up about Venus in the Nature Astronomy. So there's a journal called as Nature in the section of astronomy. So we'll take a look into that later. But before that, let's look at the parameters. Again, you can see the orbital period and the rotation period. Again, there is the interesting phenomena which you can see. And now the axial inclination is almost 177 degrees. So it rotates in the opposite side as of all the other planets. Okay, so if the planets are rotating in clockwise, it rotates in anti-clockwise. So the rotation of Venus is in the opposite direction to the rotation of other planets. Now the thing is, Venus, if you have seen Venus in the night sky with the naked eye, it appears as a very bright star. It appears as a bright star, which is why the ancient people called it as the morning star and the evening star. But the reason for that is the surface of Venus reflects 70% of the light incident on it. That is the reason why Mercury appears so bright. Venus appears so bright, and that is why it is called as the brightest object in the night sky after the moon and Sirius. Okay, so Venus is actually the brightest planet that you can see, and nothing shines more beautiful than Venus. That is why it was also named after the goddess of beauty. But regarding the other parameters about Venus, Venus and its atmosphere, it is so violent, it is so harsh that the pressure in the atmosphere of Venus is 90 times the mean sea level pressure on planet Earth. Imagine 90 times. So when you're sitting right now in your home and you have an atmospheric pressure on top of you, which we do not feel or we do not detect, but it is there. Imagine if that pressure becomes 90 times. Anything or any object that we send to Venus will be crushed to smithereens because of such a huge pressure. Apart from that, Venus also has extremely violent clouds, and those clouds actually rain sulfuric acid. So the rains on Venus are not of water, they are of sulfuric acid. And the winds are so fast that they are almost 224 miles per hour. So this is such a high speed that it is 5 times greater than the level 5 hurricanes on planet Earth. Okay, so that is how huge, or you can say violent, Venus is. The thing is, it is estimated that in the past, about 2.89 billion years ago, Venus was actually more active, you can say, and there might have been possibilities about the existence of life on Venus. Now, the greenhouse gases were actually discovered on Venus. So, the entire atmosphere of Venus is covered with greenhouse gases, which is why Venus is actually the hottest planet in the solar system. Even though Mercury is closer to the Sun, Venus is considered as the hottest planet because of the greenhouse emission. Venus also has some interesting phenomena called as Maxwell-Montes volcano. So it is a volcanic range on Venus named Maxwell-Montes, and it is as tall as Mount Everest. Okay, so Mount Everest is not only the tallest thing; there are other things in the solar system which are taller than it. Now, regarding the recent thing that was discovered on Venus about the atmosphere of Venus, it is estimated that the atmosphere of Venus has certain interesting distribution of phosphine, and the physicists and astrophysicists have found that there are traces or there are large streaks on the surface of Venus that are actually blocking the radiation from the sun. So this can only happen if there is something microbial happening there. So it is estimated, or there is a probability that there might be microbial life present in the atmosphere of Venus, about 30, you can say 30 to 35 miles above the surface of Venus. So that research has been published, I guess, about 2 days ago. You can look it up on Nature Astronomy. So that is one of the most interesting and significant discoveries in the history of mankind, finding the possible signs of life on other planet. So yeah, just like the moon has phases, even Venus has phases. So you can see this diagram anywhere. If you want, I can send you the image later on. Now comes the next planet, planet Mars, which is actually the god of war according to the Romans. So let's take a look at the parameters just in short. Now let's take a look at axial inclination. So it is roughly the same as planet Earth. So on Mars, the seasons will roughly be similar to planet Earth, although the orbit period is quite large. If you can see, the rotation period is also similar to planet Earth, which is why Mars might be possible one day that we might colonize Mars for humans. Yeah, so Mars has a very thin atmosphere, and Mars is actually so small that it's the second smallest planet in our solar system. The first is Mercury, and the diameter of Mars is almost equal to the width of Africa. So that is how small Mars is, and the entire surface area of Mars is equal to the total area of all the continents on Earth. So that is how small Mars is. There is also volcanic activity on Mars, and one of the tallest volcanic ranges in the entire solar system is on planet Mars. And the name of that volcanic range is Olympus Mons. Okay, it is the tallest volcanic range in the entire solar system. Now, regarding the atmosphere of Mars, actually the thing is Mars also has a core, it has a mantle, and it has a crust. But the crust of the Mars is rich in iron, ferrous. And the thing is, this iron or iron mineral reacts with the remnants of oxygen that is present in the atmosphere of Mars. And if you must have studied the basic chemistry in school, if iron reacts with oxygen, it gives rise to the oxide, rather the process of rusting itself. And that is why Mars gets this reddish hue. The rust has accumulated on the surface of the Mars because of this reaction between the iron on the crust and the oxygen in its atmosphere. Now, it is estimated that about 3.5 billion years ago, Mars was actually more geologically active. It had an active magnetic field. So there is a possibility that Mars might have supported life because Mars has traces of lakes, it has traces of rivers. It can be clearly seen on the streaks on the surface of Mars. So maybe long in the distant past, water was present on the surface of Mars, and we see the traces of water, and water has been found, but it is on the poles. So maybe life was there on Mars and even on Venus, but somehow there was some catastrophe and the life was destroyed. So yeah, these are basically you can see the impact craters and valleys which have been shown here, an image for you. And this is what I was talking about, the Olympus Mons. So this is yet another canyon, Valles Marineris. So you can see it is almost equal to the area of the continent of America. So yeah, the polar ice caps, which I said. So mostly water ice is present on the polar ice caps. So we might actually use this water when we colonize Mars. So Mars has two small moons, Phobos and Deimos. Earth has just one. So after Mars, so Mars is the last interior planet, but after Mars we have the asteroid belt. So asteroid belt is actually, you can say, if you see the location of the asteroid belt, it is between Mars and Jupiter. And asteroids are actually the remnants of comets. And when the solar system was in its initial stage during the formation, during that time, the chunks of rock that formed the protoplanetary disk, those started getting accumulated around the sun in rings. So some of them formed planets, they conglomerated to form the planets, but some of them remained in the rings. And this is an entire belt that has formed about 4.6 billion years ago. And that is the asteroid belt. But the thing is, you must have seen in movies that asteroid belt has so much dense rocks that you cannot pass through it, or if a rocket is passing through it, or if a spacecraft is passing through it, it has to collide with at least one asteroid. Well, that is not at all true. In fact, the asteroid belt is so much less dense that if you combine all those rocks in the asteroid belt, they will form a celestial body which is smaller than our own moon. So it is not at all dense, it is not at all that huge, and the things that are shown in the movie, that they are not actually true. So yeah, the next thing we have is Jupiter. Jupiter again is the largest planet of our solar system. It is so huge that you can almost fit 1,300 Earths inside Jupiter by volume. So that is how huge Jupiter is. Okay, imagine 1,300 Earths can fit inside it, and the diameter of Jupiter is 13. We can say not 13, 11 times the diameter of planet Earth. Okay, 11 times. So that is the humongous nature of the planet Jupiter. The mass of the Jupiter is also almost 320 times the mass of planet Earth. So Jupiter is really a giant, and it is also called as a failed star. Now Jupiter contains almost 3 by 4 matter of all the planets in our solar system. So it is really, really huge. Now Jupiter also has a core, but the thing is it has a dense liquid core. You can see the different sections of Jupiter's interior. It has a heavy element core, then we have liquid nitrogen and liquid metallic hydrogen. Okay, and you can even see the comparison, although this is not a scaled model, but they have just shown you a diagrammatic representation. Now the Great Red Spot. So this is a really interesting phenomenon on Jupiter. It is actually a cyclone that has been formed because of the convection currents. So on Jupiter, you see the Great Red Spot, and it is so huge that you can almost fit 1.5 Earths inside that spot itself. That is how huge it is. Imagine that Great Red Spot, you have your entire world and plus half of your world fitted in. So that is the Great Red Spot. It can be seen through the telescope very easily, and it is really attractive to see. Now, many of the people believe that Saturn has rings, only Saturn has rings. But the thing is, Jupiter, Saturn, Uranus, and Neptune, all of them have rings. The only difference is Saturn rings are more predominant and visible, but all of them have rings. And this is actually an image of Jupiter and not Saturn, which you're seeing right now. And then again, Jupiter has 79 confirmed moons, out of which these 4 are the major moons. These are called as the Galilean moons, which were discovered by Galileo, out of which Io. So Io is considered as the most volcanically active object in the entire solar system, or you can say the most volcanic object of all the moons in our solar system. So that's Io. And then you have Ganymede as the largest moon of our solar system. So out of all the moons in our solar system, Ganymede is rank one. And the other are Europa and Callisto, Ganymede, Io. So these are the four Galilean moons. And there are other 79 moons that have been confirmed. So now comes Saturn. Saturn, the crown jewel of our solar system. So now Jupiter actually means the father of gods, and Saturn, the god of agriculture, is called the father of Jupiter. So now Saturn itself is also so huge that almost, let's say, the diameter of Saturn is 10 times as wide as diameter of Earth, and you can almost fit 765 Earths inside Saturn by volume. So that is how humongous these planets are, and hence they are called as the gas giants. And in spite of being so large in size, they are completely gaseous. It does not have a true surface or a solid surface. So the thing is, one of the most interesting parameter of Saturn is its density. So Saturn is so much less dense that if you take a big enough ocean that you can support Saturn, Saturn will actually float on the surface of water. So it is so light that its density is so much less than water that Saturn actually floats on the surface of water. Now Saturn also has rings, of course. The thing is, core of the Saturn is water ice, and it also has rocky material. It is made of gases, liquids, and yellow ammonia crystals. Now the rings of Saturn, as you can see, they have been divided into types. We have the D section, C section, A, F, G, and E section. And these sections are, of course, composed from different objects. Okay, so the thing is, these rings stay in shape around the equator because of the bigger moons of Saturn, which are called as the shepherding moons. So because of the gravity of the shepherding moons, all the other rings stay in shape along the equator. So yeah, this is a picture to give you an idea about the composition of the Saturn's rings. Yeah, so among the satellites of Saturn, Titan is the only moon with clouds, and it has a dense atmosphere. And the thing is, Titan also has lakes, it also has rivers, it also has seas, you can say. The only difference between the lakes, seas, and rivers on Titan and the ones on the Earth is that the lakes, rivers, and seas on Titan are of liquid methane. So imagine maybe one day a life form which does not require water as the prime element or the fundamental element of life, maybe a life form which requires liquid methane as the prime element, that will evolve on Titan. And we might have another form of life in our own solar system. So that's really exciting on the surface of Titan. And we have launched missions called as Cassini-Huygens, which have actually landed on the surface of Titan. So yeah, this is the planet Uranus. Now the thing about Uranus is so far away from the sun. It is so far away that you can experience all seasons on Uranus only once in your lifetime. And the duration of the seasons is so much that each season lasts for 20 years. So imagine being stuck on Uranus in the summer season for 20 years, or in being stuck on Uranus for winter for 20 years. So that is one of the most interesting things. Another interesting thing that you can see in the parameter itself is the axial inclination. So where other planets had the axial inclination of almost 23 to 24 degrees, Uranus here has the axial inclination of almost 98 degrees. So the thing is, Uranus does not rotate vertically, it rotates horizontally. So where other planets have their equators, Uranus has its poles. So only one part of Uranus is exposed to the sun while the other is in dark. So that is another yet scaring phenomena on Uranus. Apart from that, Uranus is also a huge giant, and it is called as a ice giant. The diameter of Uranus is 4 times the diameter of planet Earth. So now regarding the discovery of Uranus, so if you see the chronology, Jupiter is the father of all gods. Saturn is the father of Jupiter, so naturally the next planet should be the father of Saturn. And so it was named as Celos in the Roman mythology, although it was named by Johann Bode because Uranus and Neptune are the planets which cannot be seen with the naked eye. Without the invention of the telescope, it is impossible to see Uranus and Neptune. So, if you hear any claims from the people that ancient Indians or ancient Greeks knew about Uranus and Neptune, it is completely false. Okay, don't believe on such false assertions and claims. Uranus and Neptune were not known to any of the ancient civilizations. They can only be seen if you have a telescope. And William Herschel, by chance, discovered Uranus, and later it was changed to Uranos, which is a Greek term which is now mispronounced as Uranus. So this is the only planet which is named in the Greek as per the Greek mythology. All the other planets are according to the Roman mythology. Yeah, so as I said, even Uranus has rings. Jupiter, Saturn, Uranus, and Neptune, all of them have rings. And the surface is made of water, ammonia, and methane, which is why Uranus appears blue. So this is regarding Uranus. Okay. Now we have the satellites of Uranus, and believe me, all these satellites can be seen through a 14-inch reflector telescope. You can actually see this image, and this image is in infrared, but you can actually see how it represents. This is not some artistic representation, this is an actual photo, and you can see such things with the help of a powerful enough telescope. So yeah, this is the last planet of our solar system, the Neptune. So again, if you try to look at it, on Neptune, it is so far away from the sun that it takes 165 Earth years to complete one revolution around the sun. It is so far away. And seasons on Neptune last for 40 years. Imagine, so you are being stuck on Neptune with the summer season which lasts for 40 years. And the other important phenomena is it actually rains diamonds on Neptune. Yeah, believe me, it rains diamonds on Neptune. Now, Neptune has a solid core, water ice, and silicate rock. And it has pressurized oceans and clouds. Now, the thing is, on Uranus, in the atmosphere of Uranus, the winds are so fast that their speeds range of about, up to about 12,000 miles per hour. That is how fast the winds are. They are so fast that they actually become supersonic and they break the sound barrier. So, if you must have heard when a jet is passing by in the sky, you hear a loud crackling noise. That loud noise which you see is because of the shock wave that is emitted from the plane, from the nose of the plane. Similarly, a bow shock is formed in the atmosphere on Neptune because the winds are so fast that they break the sound barrier itself, almost 1200 miles per hour. They're so strong that they are 5 times stronger than the level 5 hurricane on planet Earth. And then again, it has 6 rings. It has 14 known moons, and its most major moon, rather its major moon is Triton. Okay, it is named after the sea god. Yeah, so this is a review about the rings of Neptune. Then we have the satellites of Neptune. So Neptune is not where our solar system ends. There is something beyond Neptune, and that is the Kuiper belt. So now the question comes is, when we were trying to define your address, the first line was planet Earth. The next, we have our solar system. Okay, but even now, the solar system is not complete. There is something beyond this, and that is actually the Oort cloud. Oort cloud is a cloud where the comets come from. It is the origin of most of the comets, and that is what encloses our solar system. And this is where most of the comets come. So this is the second line of cosmic address. The first is planet Earth. The second is solar system. So what is the third? So yeah, this is the third line, or you can say the cosmic address line, Milky Way. If you can see, Milky Way has more than 5 billion stars and it has more than 11 billion planets. It is so huge that you can see the sun appears as a minuscule dot. Okay, it is literally negligible in front of all the other stars. The Milky Way is so huge that the diameter of Milky Way is 1 lakh light years, 100,000 light years. So imagine if you want to go from this side to that side with the speed of light, you will still need 1 lakh years to cross the Milky Way. That is how huge it is. That is, you can say, gigantic it is. And we are just one Our sun is just a minor average star in of all the billions of stars in the Milky Way galaxy. And this is the next line of cosmic address, the Milky Way. And this is, of course, a diagrammatic representation. So, what lies beyond the Milky Way? So, just like we have neighbors, even Milky Way has a neighborhood of galaxies. So, the galaxies which are closer to the Milky Way are called as the local group. It consists of almost 10 to hundreds of galaxies, and that is called as the local group, the neighborhood of Milky Way galaxy. This is the next line of cosmic address, but there is something beyond this, the supercluster. Now, try to imagine each point of light. Okay, I'm not saying each version, a stream of light, each point of light represents a cluster of galaxies. Okay, each point of light, each and every point of light that you're seeing right now represents a cluster of galaxies. And this is what you call a Virgo supercluster. It is a subset of Laniakea supercluster. So if you guys have seen Cosmos, this is actually the image from the Cosmos, which I've used. You can see at the bottom, Cosmos Fog Century. So this is the next line of cosmic address, the Virgo. Then we have the last line of cosmic address, the observable universe. So if you want to see our location, this tiny thing at the center, which I'm circling with my arrow, on the left side of the local group, that is where the Virgo supercluster would be. So imagine the last line, the observable universe, has hundreds and thousands of superclusters, out of which our Virgo supercluster is just one. Our supercluster is a home to hundreds of groups of galaxies, out of which local group is just one. Local group has hundreds of other galaxies, out of which Milky Way is just the one. And even Milky Way has more than 5 billion stars, out of which Sun is just an average star, which has 8 planets, out of which our planet Earth is the one. And you're living on that planet in a nation called India, in a state called Maharashtra, in a city called Pune, and you're observing all of this. So imagine how astounding or astonishing this is to know the universe in spite of being so minuscule. So this is how you define the cosmic address to an alien which is outside the universe. So this is the last line, the observable universe. Now this is the end game. Now this is completely theoretical and we are entering the world of science fiction. We have no proof of a multiverse, but there are theories that predict the existence of a multiverse, but it is not proved yet. So this is like a universe in a nutshell. You can see a diagrammatic representation. So the thing is, how far will humanity go? So if you're looking at the image in front of you, this image is called the Hubble Ultra Deep Field. So this image was taken by Hubble Space Telescope. Now the specialty of this image is, imagine you're holding out your thumb towards the sky. Okay, not even thumb, your little finger towards the sky. So the area of the sky, which is covered behind the fingernail of your little finger, okay, just that fingernail, only that much area of sky represents 1 degree, okay, 1 degree of sky. Hubble Space Telescope took a photo in just 1 degree of sky, which can be easily covered by your fingernail, okay. In that single degree of sky, Hubble Space Telescope found all these galaxies. There are more than 5,000 galaxies in that single degree of sky. And hence it is called as the ultra deep field. So all these galaxies, even the distant red dots in these images, are galaxies which are really, really far away from us. And these are called as the population 1 galaxies. So you might be wondering, if you start walking into this image, how will it end? If you keep on walking and if you hit, let's say you hit a dark wall, does that mean you have reached the end of the universe? Well, no. What you have reached is the limit of Hubble's vision. This is the image that can be captured by Hubble Space Telescope with its specification. But this is not the entire picture of our universe, just 1 degree of sky, and yet 5,000 galaxies. So to take, you can say, in order to understand the perspective, Voyager 1 was one of the fastest man-made objects ever, okay, ever. It has the speed of 67,000 kilometers per hour. Oh, sorry, 62. So imagine 62,000 kilometers per hour is the speed of the Voyager. It is one of the fastest man-made object. So let's say Voyager is traveling to the nearest star to our solar system. which is just at a distance of 4 light years. Okay, just 4 light years. The time that will be required for the fastest man made object to reach the nearest star to our solar system in the damn entire universe. Even then, Voyager will require 75,000 years to reach there. So imagine how vast cosmos is. If the nearest star is Alpha Centauri, just 4 light years away, and yet we are going to need 75,000 years to reach there with the fastest thing known to us. So imagine the diameter of our galaxy was 100,000 light years. So, in short, humanity is going to be really stranded. So, how far can we go? So, if you look, we can go away from the Earth, that's fine. One day we will travel the inner solar system, even that is fine. We will travel the outer solar system. Eventually, let's say thousands of years later, we will be going to the closest stars. And let's say millions of years later, if somehow humanity finds a way to settle on other planets, we might even explore our own galaxy in its cosmic neighborhood. But this red box is where we are going to be stranded and quarantined forever. There is no way we can leave this local group ever, no matter how fast you travel. We are stranded on this local group, and let me tell you, the local group represents only 0.00000000001% of the observable universe. Imagine 0.90s and a 1% is the local group. That is how small local group itself is, and we are never going to leave this. So that means almost 99.999999% of the entire universe is going to be unknown to us. So this is one of the most depressing things that we can learn from modern astrophysics. So then how old is the universe? So just like we have our own, and this is the last point by the way, how old is the universe? So you must be knowing that our calendar shows you 1 year and there are 12 months in that calendar. Our calendar has the months which long for a duration of 30 to 31 days roughly, and each day stands for 24 hours. But then our universe is 13.87 billion years old. Now, you might say that this is just a number, and it is really difficult to contemplate this number. But let's try to take it a perspective. If we want to represent the entire age of the universe in a single calendar of 1 year, we will have to change the parameters. So, in the cosmic calendar, in the cosmic calendar, 1 month will not stand for 30 days, it will stand for 1.2 billion years. So when you're going to even transition from 2 January to 2nd of Feb, that period of 1 month does not stand for 30 days. It means you have crossed a time span of 1.2 billion years. And each day in the cosmic calendar stands for 40 million years. Okay, so just remember, when you move from 3rd of Jan to 4th of Jan, you're not passing 24 hours, but a 40 million year duration has elapsed. Okay, only then we can represent the entire age of the universe in a single year. Okay, so now let's take a look at events, all the events that have happened in the scale of cosmic calendar. So before that, our universe began on 1st of Jan, 0 hours, 0 minutes, 0 seconds. There was a huge, you can say, cosmic inflation, which gave rise to all the things that we know today, space and time fabric. And that came on 1st of Jan in the cosmic calendar at 0 hours, 0 minutes, 0 seconds. So when were the earliest galaxies formed? So if you want to see the emergence of the earliest galaxies and plot them in your cosmic calendar, this is when they came in, on 22nd of Jan. Now remember, one day stands for 40 million years. So when you're talking about 22nd of Jan, which means 40 million into 21 years have already elapsed, and that is when the earliest galaxies were formed. Our own Milky Way came on 16th of March. So imagine 2 months have already elapsed. 1 month stands for 1.2 billion years. So 2 such months have elapsed, and plus 16 days of the month of March. Each day stands for 40 million. So on the cosmic calendar, if you want to plot the emergence of Milky Way, that will be on 16th of March. Yeah, so our own solar system came so late in the cosmic calendar. It was formed on 2nd of September. Already 8 months have elapsed, and even then, another day of September. So imagine almost 8 billion years have elapsed since the formation of the universe, and then is when our formation of a solar system began. So late. At the center, we have the sun and we have the protoplanetary disk where the planets are being formed. So, this is something more familiar to you guys because you are from the medical field. But the prokaryotes, the emergence of prokaryotes, if you want to plot the emergence of prokaryotes on the planet Earth, I don't even know if the images of the prokaryotes, let's just assume. But the emergence of prokaryotes on the planet Earth and plotting it on the cosmic calendar gives you a time period of 21st of September. So imagine the inferior signs of life were so late on planet Earth. The dinosaurs, the emergence of dinosaurs on the cosmic calendar comes on 25th of December, Christmas Eve. That's a good gift. Dinosaurs. Yeah, so apes. Now just take a look at the date. 31st of December at 6:05. Now even time is considered to be of importance, and we have the hours as well. So in the cosmic calendar, the emergence of apes came on 31st of December at 6:05 in the morning. That is where our first common ancestor came into existence. So what about all the other aspects of humanity? So let's take a look at it. Yeah, so the date is 31st of December. It is the last day in the cosmic calendar at 10:24 p.m. That is when the first primitive humans and stone tools came into existence in the last day of the cosmic calendar. So yeah, just take a look at the time. It is already 11:44. Okay, almost in the last 15 minutes. The cosmic calendar year is going to end in 15 minutes, and that is when humans have invented or rather domesticated fire. On the last day, in the last 15 minutes. Now just take a look at the time. 11:58. It is 2 minutes to midnight. And that is when we actually invented sculpture and painting in the cosmic calendar. So all the other events, major events on 31st December are, if you try to take a look at it in the terms of cosmic calendar, since the conception of the universe and relating to it, Indus Valley and Indus Valley civilization just came 12, or you can, yeah, just came 12 seconds ago. Buddha came 6 seconds ago almost. Christ came 5 seconds ago. Mahamada came, I guess, 4 seconds ago. And it was not even 2 seconds ago that the two halves of the world met each other by the voyage of Columbus. Just in the last 2 seconds is when we invented or we can say we started voyaging from one continent to another. And the entire modern history that we learn in school, all of the modern history is just in the last second of the last minute of the last hour of the last day of the cosmic calendar. Our entire history of humanity is concentrated in the last second in the cosmic calendar. So it is in this last second when Galileo observed the moons of Jupiter for the first time, and it is also in this last second in which humanity landed on moon. And it is also going to be in this last second when we will, rather, when humanity will land first on Mars. So that is how minuscule our existence is in comparison to the creation of events in the cosmos. So let's just summarize the talk. Of course, the universe is very, very big, which we learned today. The universe is, of course, very, very old, which we learned again in the perspective of cosmic calendar. It is 13.87 billion years old. So this is another important thing. We have no evidence as of yet about any. Now the Venus thing just came in, but there is no evidence yet. It is a supposition and a probability that there might be life on Venus, or there might be signs of microbial life. But for now, we have not found any signs of intelligent life anywhere in our galaxy. I'm not saying solar system, I'm saying galaxy. Okay, so for now, without the evidence, we are completely alone in this big and old universe. We try to call others from our radio telescopes, but it seems that no one is answering us and no one is returning our calls, and neither is anyone calling us on their own. So we are all alone in this vast world. We are going to be trapped in the local group for eternity, which is again just 0.9 zeros and 1%, of the total observable universe. Yeah, so this is not actually something we need to know. One day we all might die. And the positive side of this is, so will the universe. So the universe will eventually end its lifespan when the last black hole evaporates. Okay, that will happen about trillions and trillions and trillions, 8 times trillions of years later, according to the astrophysical theory of heat death. Okay, so even the universe is going to end one day. Nothing lasts forever. So today we learned a summary, and you can say in this topic we learned about solar system, our cosmic address, about planetary atmospheres, and also about how old our universe is and how we can represent that in a cosmic calendar to find out about our minuscule existence. So yeah, this is just a page of our, you can see the contact on the right hand side of our organization. Our association is completely based on volunteer workforce. Okay, so all the lecture that I conducted today is only because I'm a part of this organization and we get to learn new things from these organizations. Even Rishi is a part of our organization. So if you want to learn astronomy, even as a hobby, you can join us. We have an office at Tirak Smarak Mandir on every Sunday between 6 p.m. to 9 p.m. And on the left hand side, if you want to, if you want any contact regarding the PPT that I have presented today, you can contact me on my details. So yeah, I guess today we'll wrap up the topic, and I request Rishi to take over. I'll stop sharing.
Thank you so much, Bhargav. That was a really engaging session, and I'm sure everyone learned a lot today. So now we have a short question and answer session. So
Yeah,
if
sure.
anyone has any doubts, then you can type your name into the chat box, and then I'll call you one by one. Okay? We'll just wait for anyone to ask their doubts. And meanwhile, actually, I had a doubt too. You mentioned in the talk that we are quarantined to our local cluster. Why is that exactly?
So yeah, the thing is, there is something called as a dark energy, which is coming recently right now. So dark energy is the opposite of gravity. So gravity is responsible for attraction, but there is a phenomena called as the cosmic expansion, which is a result, which might be a result of dark energy. So dark energy tries to oppose things, and that is why everything outside of our local group, which is not bound to us by gravitational field, is going to move away from us forever and faster than the speed of light. So that is why it is unachievable for us to reach there.
Okay. And just one more thing, you were mentioning that there is the last line of our address is the observable universe. So could you tell us a few words about that? Like, what is the unobservable universe?
Yeah, sure. So there is a difference between the visible universe and the observable universe. So if you just take a simple formula of speed is equal to distance upon time, okay? So you know the speed of light and you know the age of the universe. So if you multiply those things and also take into consideration that since the beginning of the universe has expanded. Okay, so that expansion is taken into account, and we can see that the radius of the observable universe comes to about 45 billion light years. So that is the cosmic limit up to which we will ever see the universe, and hence it is called as observable universe. And visible universe is the one which we see with all the visible light and through the telescope.
Okay,
Yeah.
so if anyone else doesn't have any doubts, then I'd like to hand over the screen to Rohit Mehta, who is our club secretary and the co-head of Zenith Astronomy Club. Over to you, Rohit.
Hi, I'm Rohit Mehta. I'm the College Club Secretary and the founder of Zenith and the co-head of Zenith along with Rishi. And on the behalf of Zenith and everyone who was a part of this event, I would like to thank Bhargav and JVP a lot for this informative and wonderful event. And I mean, I hope we can do a more of these events in the times to come. And let's keep our fingers crossed and hope that we can do this under the actual night sky. Once the Corona scare pans out and stuff. So I hope whoever's here, everyone has enjoyed and learned a lot. And again, thanks a lot, Bhargav, and thanks a lot, JVP. And I mean, Great work, Rishi. I mean, Rishi was instrumental in organizing this. So that's great work. That's all. Thank you.
Yeah, thanks a lot. The word of thanks.
So with that, I'd like to bring this meeting to a close. I think that's it.
Okay, thank you all for attending. Bye bye.
Okay, thank you everyone. Bye bye.